All right, let's jump right in because today we are tackling an absolute monster of a challenge, the Cambridge 9618 Computer Science exam. But I want you to completely shift your mindset right now. Stop picturing this exam as just a simple, boring test of your memory. Instead, I want you to view it as a high-stakes chess match. Because to win this game, to actually secure that A-star, you literally have to think 5 moves ahead of the examiner. You have to anticipate exactly what their next mental move is going to be when they're grading your paper. Today, we are zeroing in on one specific, highly critical area that trips up thousands of students every single year. We're talking about professional ethical bodies, specifically the IEEE, the Institute of Electrical and Electronic Engineers. To really set the stage for this, let's look at a real Cambridge computer science past paper question. We'll use a classic scenario, similar to past paper code 9713. Imagine we have 2 perfectly typical students taking this exam. We're going to call them Alex and Sam. Now, Alex is what I call the overloader. When Alex sees an IEEE ethics question, he completely panics. He just overloads the paper with raw computer science facts. He's spilling out every single historical detail about the IEEE, regurgitating textbook definitions, but he offers absolutely zero real-world analysis. Then, on the other hand, we have Sam. Sam is the rusher. Sam's looking at the clock, rushing through the paper, and completely misses the specific command word requirements in the prompt. Sam just writes a super generic, vague paragraph that doesn't actually answer the question asked. If you put both of their answers side by side on a split screen, you'd see they are completely covered in red pen marks from the examiner. Absolute bloodbath. Why? Because neither of them had a strategy. They were playing checkers while the examiner was playing chess. Mastering the strategy behind these professional ethical bodies is the absolute key to dominating the board, and that's exactly what we are going to fix today. Look at this quote from a senior examiner. It is a known fact in the marking rooms that the difference between a B and an A-star in computer science often comes down to how well you understand professional ethical bodies, specifically the IEEE framework. This isn't just my personal opinion, this is direct insider insight. The stakes here are incredibly high. This is the exact trap that caught our friend Alex. Alex ended up with a B because, sure, he showed a lot of knowledge, but he completely lacked the critical evaluation of how those IEEE standards actually apply to the specific coding scenario in the question. Listen carefully. The examiner is not asking you to be a walking Wikipedia page. They literally do not care how many random facts you can memorize. They're asking you to be a strategic thinker. Throughout this entire masterclass, we are going to take those red pen marks that Alex and Sam got, and we are going to actively transform them into green check marks. We're going to decode exactly what the examiner wants to see so you can lock in those top marks. To do that, we need a clear roadmap for today's session. We'll be hitting the core principles, then diving into the procedural framework, reviewing some strict examiner warnings, breaking down critical analysis, and wrapping up with evaluation and method marks. Let's kick things off with Section 1, Core Principles. These are the absolute foundational rules of the game. To win this chess match, you first have to understand the theoretical architecture of the IEEE framework. It rests entirely on precise definitions, causal relationships, and integration. The Cambridge Assessment Framework targets distinct cognitive domains. These are knowledge and understanding, application, and analysis. Think back to Alex. Alex only hit the knowledge and understanding domain. He memorized the IEEE Code of Ethics perfectly, but he totally face-planted when it came to application and analysis. The academic benchmarks for these IEEE questions require highly logical, structured reasoning, and this is exactly where we need to introduce our secret weapon, the PEAL framework, Point, Evidence, Explanation, Link. Top-tier students use PEAL to structure their computer science answers, especially for ethics. Whenever you see a complex command word like evaluate or discuss regarding IEEE standards, you don't just ramble, you make your point. You provide evidence from the given scenario, you explain the technical impact of that evidence, and finally you link it all back to the overarching ethical principle. I want you to test yourself right now. Mentally picture a paragraph that just blindly lists facts versus one perfectly crafted using the PEAL structure. A PEAL paragraph hits that critical analysis domain every single time. It takes the given data, applies an IEEE principle, and analyzes the actual outcome. So the absolutely crucial takeaway here is this. Cross-topic connections achieve significantly higher marks. This is your first true grandmaster move. The conceptual framework for IEEE draws heavily on established principles of systematic analysis and evidence-based reasoning. You must link IEEE definitions to completely different syllabus areas. For example, if you get a question about data structures or database security, linking a technical system failure back to a violation of IEEE professional ethics shows top-tier, A-star understanding. Principal examiner reports specifically highlight that candidates who do this achieve significantly higher marks. Before we continue, subscribe to our YouTube channel Ace the Exams.
at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, the procedural framework. This is the tactical methodology you need. This is where the magic happens. This is where we start physically transforming those flawed, rushed answers into perfect green-checked A-star responses. Your data interpretation skills here are absolutely critical. You have to extract information from the prompt, perform any necessary calculations, and draw evidence-based conclusions. Systematic processing within the IEEE framework follows a very strictly standardized sequence. Look closely at these 5 steps on your screen. 1. Identify the key elements of the scenario. 2. Apply the relevant IEEE principles. 3. Execute your analysis with perfectly clear working. 4. Verify your results. 5. Present it all in the appropriate format. Imagine a 60-second timer ticking down on your screen right now. If our students, Alex and Sam, were forced to rewrite their disastrous answers using just these 5 steps, the transformation would be night and day. Instead of panicking, they would identify the specific ethical dilemma, apply the specific rule, and execute their reasoning step by step. Examiners are actively scanning your paper for this exact sequence when they grade your systematic processing. If you skip step 3 and just magically jump to the conclusion, you are going to bleed marks.
Now let's look at how this builds directly into algorithmic thinking. Algorithmic thinking in an IEEE context requires step-by-step decomposition, appropriate data structure selection, efficient code implementation, and incredibly rigorous testing. You might be sitting there wondering, wait, why are we talking about coding structures in an ethics section? Great question, because as a professional adhering to IEEE standards, writing inefficient, untested code that fails boundary conditions isn't just bad programming, it is a massive ethical failure. If your software runs a hospital and it crashes because you didn't test it, you violated the IEEE Code of Ethics. You have to apply algorithmic thinking directly to your professional conduct. It's all connected.
Let's dive into Section 3, Examiner Warnings. We need to look at the exact traps that are failing students. Here are the absolute top 3 mistakes pulled directly from Cambridge Principal Examiner reports. Number 1, the classic trap in IEEE questions is using the wrong formula or algorithm for the specific context. Number 2, students completely forget to check boundary conditions and edge cases. Number 3, answers severely lack specific context from the actual question prompt. Let's do a quick find the flaw challenge. Imagine reading a student's paragraph that says, the software engineer should write good code and test it well to follow IEEE rules. What is the flaw there? Think about it. It completely hits mistake number 3. It lacks all specific context. It doesn't mention the boundary conditions, it doesn't mention the specific algorithm, and it completely ignores the actual scenario provided in the exam paper. It's generic fluff. Failing to check edge cases or ignoring specific context will absolutely cost you the A-star. Whether you're studying for 0417, 0478, 0983, 0984, 2210, or the ultimate boss level 9618, these rules apply. Always anchor your answer to the context, the edge cases, and the algorithm. Stop scrolling, subscribe to our YouTube channel Ace the Exams at aceexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to aceexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's shift gears to Section 4, Critical Analysis. This is where we separate the A-stars from everybody else. This is the advanced framework that differentiates top-tier candidates. This is where we integrate our command word decoding with our critical thinking skills. High-level problem solving in the IEEE context uses what we call the DSE methodology. Deconstruct, solve, evaluate. First, deconstruct. You identify the given information and break the problem down into logical, bite-sized steps. Second, solve. You solve systematically and always check for reasonableness. Third, evaluate. You make highly justified recommendations. This pairs absolutely perfectly with our Peel framework. Let's kick off an interactive workshop right now. Challenge 1, Data Scan. Imagine a complex computer science data table on your screen with a 60-second timer counting down. You need to extract the core trend. You deconstruct that data to find your point and evidence. Then you solve it by explaining the technical steps required. Finally, you evaluate by linking it to a justified recommendation based purely on IEEE ethics. That is how you compress complex, messy data into high-scoring paragraphs. Now, for Challenge 2, find the flaw. What happens when the command word asks you to compare? Comparative analysis requires a very, very strict approach. You must identify both similarities on one side and differences on the other. But listen to me, that is not enough. You must use comparative connectives like whereas, however, or in contrast. You must support each comparison with actual evidence from the text, and crucially, you must draw conclusions about their relative importance. If you only list similarities, which is exactly the mistake our rusher Sam made earlier, you instantly lose half the marks. Just like that, gone. You have to play both sides of the board.
For challenge 3, let's do some speed writing. Imagine you have 30 seconds to write one perfect Peel paragraph. When you are doing critical analysis of code within an IEEE context, you have to evaluate the algorithm's quality using strict criteria. You must specifically identify the time complexity, the space complexity, the edge cases, and their direct effect on overall performance. You cannot just write that an algorithm is fast or slow. The examiner will laugh at that. You have to use professional terminology. An IEEE professional analyzes whether the time complexity, like big O of n squared, causes an ethical failure by delaying critical medical data in an emergency room system. That exact level of detail, that precise technical connection to an ethical outcome, is exactly what the examiner is hunting for.
Finally, we've arrived at Section 5, Evaluation and Method Marks. Let's talk about your ultimate safety net. This right here is the strategy that secures crucial points even when things go completely wrong and you find yourself totally backed into a corner on the chessboard. Look at this massive examiner alert on the screen. Thousands of students lose marks simply by not showing their working. Even if your final answer is completely 100% wrong, method marks can save you. You have to show your working. This is the method mark strategy. Examiners literally award marks for the systematic process and the clear working itself. If you lay out that 5-step standardized sequence we discussed earlier, and you make a silly minor calculation error at step 4, guess what? You still get the marks for steps 1, 2, and 3. But if you just write down the wrong final answer in the box with absolutely zero working, you get a 0. It's that simple. So what is the complete ultimate computer science answering system? It all boils down to 3 golden rules that guarantee top marks. Rule 1, command word decoding. Know exactly what evaluate, compare, or discuss actually means. Rule 2, Peel framework application. Always use point, evidence, explanation, link. Rule 3, time management matrix. Allocate your time based strictly on the method marks available, and always, always show your working. That is your cheat sheet. That is your path to 100% mark potential. So, as we wrap up this masterclass, I want to leave you with a provocative question to really think about. What is your target grade for Computer Science 9618, and what is the biggest challenge currently standing in your way? Think about the strategic moves you need to make right now on the chessboard to achieve that A-star. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at ACEXams_IGCSE to excel in your Cambridge examinations. Subscribe right now to ACEXams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.